Good afternoon, everyone. A few housekeeping items. Turn off your cell phones or put them to vibrate. Reminder, please complete evaluations on the mobile app before you leave. We need your feedback. CEU information is available at the back of the room. Ask a room monitor for assistance or visit room N115 for any questions. Please make sure to have your badges scanned. Scanning badges will confirm your attendance for CEUs and attendance certificates. And be sure to visit the show floor for more educational opportunities and check out the mobile app for details. So our presenters today, we have Scott Conwell with the International Masonry Institute. Scott is a licensed architect and director of industry development with the International Masonry Institute. He has authored technical articles, published industry-wide, and is a frequent speaker at regional, national, and international conferences. He is a delegate to the ANSI A108 Accredited Standards Committees for Ceramic Tile and the TCNA Handbook Committee and the Tile Marble Terrazzo Labor Management Craft Committee of the IUBAC. Scott is a fellow of the American Institute of Architects and the Construction Specifications Institute, and he is the 2021 recipient of the Tile Contractors Association of America Carl V. Cesare Award for service to the ceramic tile industry. And we also have James Wolfel of Artcraft Granite Marble and Tile Company. With 3 decades of experience as a professional tile contractor, James Wolfel is the president of Artcraft Granite Marble and Tile Company in Mesa, Arizona, where he serves as the chief operating officer of this third-generation family company. He is a tireless advocate for higher standards and proper methods as shown in all aspects of his work. James' technical acumen is evidenced through his role as a chairman of the prestigious NTCA Technical Committee, a role he has held since 2007. His technical knowledge and professional standards are also why he is one of the few tile contractors in the United States to sit on the Tile Council of North America Handbook Committee for tile installation and the ANSI A108 Committee for ceramic tile installation. In 2016, he became the only tile contractor in the world to be invited to speak at the World of Congress Ceramic Tile Quality in Castellón, Spain. James is honored to have earned the distinction of Tile Person of the Year in 2011 for his work in developing the Stone Installation Guide as part of the NTCA Handbook. James was recognized with the NTCA's prestigious Ring of Honor for contributions to the NTCA and the tile industry in 2019 of October. James is a principal in the tile and stone consulting firm J.G. Wolfel & Associates, which provides forensic deconstruction and investigation, job site inspections, installation, and forensic reports, and expert testimony. Thank you.
All right, thank you very much, Sam. Thank you guys for coming. You had to choose between family businesses and exterior tile adhered veneers, so we're glad you're here. We got a lot of ground to cover. I'm Scott, this is James. Our outline is going to be, I'm going to talk a little bit about definitions to give you some context to see, so you can understand how tile fits into the building code. That'll be part 2. And then we're really going to take a deep dive into what happened over the last 10 to 15 years in the world of tile. And, you know, some good stuff and then some growing pains and things like that, and how we got where we are today, which is proposing changes to the International Building Code and actually getting those changes approved. Before we get going, though, I want to just quickly ask, it's always helpful for the presenters to know who the audience is. How many tile contractors do we have? Tile contractors or installers, tile setters, also raise your hands. Any architects or interior designers? Good, welcome. Building owners, facility managers, those types? All right, I think we got most of them covered. All right, so let's jump in. I think it's always helpful to talk in terms of definitions so that when we say the word masonry and the words like veneer and gauge porcelain tile, everybody understands. So you may be thrown for a loop. Masonry, why would you include that? Well, we're going to get to that. You're going to understand that adhered tile is a subset of this material called masonry, according to the International Building Code. Most people think masonry is bricks, but you should know, for the sake of this conversation and for the sake of the International Building Code, masonry includes adhered material like you see, adhered tile, also anchored tile. So what's a tile? Well, I think we all know what a tile is. I'm not going to read the definition to you, but if you want to glance at the definition, this is how the ANSI A137.1 standards defines tile. And I highlighted that last sentence because it says to produce specific physical properties and characteristics. And those specific properties are found in tables 6 through 10. And that's the real definition of tile. You have to look at those tables and really understand what the performance criteria are. And I just threw a table up here to show you, we're not going to talk about any of this, but just to show you the type of information that goes into defining what is a porcelain tile relative to a glazed wall tile, relative to a pressed floor tile. These are very distinct types of tile, and the ANSI standards do a great job of describing them and defining them. We're going to focus on porcelain today because really we're talking about the code changes for exterior porcelain. So if you don't know already, 0.5% moisture content or less is the defining characteristic. There's a lot of other things that go into making a porcelain tile, but a porcelain tile has to have 0.5% moisture or less to be a porcelain tile. And here are some other variations of porcelain tile, or some other defining characteristics: the raw materials, the absorption. Porcelain is one of those types of tiles that can be either calibrated or rectified, and that has to do with the how exacting and precisely the manufacturing of them are. And now you may have heard this material thrown around: gauge porcelain tile panels and slabs. These are the definitions for those coming straight out of the ANSI A137.3 standards. Hopefully by now everybody knows what this material is. If you don't, you don't have to go far. There's a million examples on the show floor, which we love. But I don't want to say scary, but the great opportunity we have now is we can stick this stuff up on building exteriors. But we have to be very careful how we do it, and we have to really, really understand some of the restrictions and rules and parameters to enable us to do that. All right, almost done with definitions. We're going to go veneers. It's an exterior finish of wall system which transfers out of plane loads, but it doesn't participate in the load-bearing capacity, whether horizontal or lateral loads. A veneer does not take up any load capacity. The building code tells us there are two types of veneers: anchored veneer and adhered veneer. Basically, anchored veneer is when you're tying the brick or the stone or the tile back to the structural wall backing with a system of wall ties or anchors that serve a structural function to, a mechanically attached tile. We're not going to talk about that because the code, we're focusing on adhered. Adhered is when just like it sounds, we're adhering the tile material to the backing. So the example on the left is anchored. The example on the right is adhered. Now the cladding in the picture shows a thin stone veneer. You can, it can be tile, it can be porcelain tile, all kinds of thin brick, all in the family though, all in the family of adhered veneers. And when the code, by the way, the code doesn't really make any distinction on what the cladding is when we talk about adhered veneers, which we'll show you in a minute. So just by way of contrast, you can see some examples of anchored systems. And then here are some examples that illustrate a variety of adhered systems with cladding materials like rubble stone and thin brick to standard tile to large format tile, and backing systems like wood studs and sheathing like you'd have on a house or something, cement board, glass mat reinforced gypsum, and concrete block and cast in place. And I know James is going to talk a little bit about tilt-up in his area. Tile goes up over tilt-up. And I believe you're going to even talk about a few failures when we...
Well, I think tilt-up is right now is a regional type thing. So I think a lot of tilt-up's going in Las Vegas as well as Phoenix.
Mm-hmm. Good. All right. So now I'm just going to kind of put it all together before we dive into part 3. Let's look at how porcelain tile is defined by the building code. And we say the building code, it's the International Building Code, comes out every 3 years, 06, 09, 12, 15, etc. And I want to just give you a little bit of history or a little bit of structure. The IBC has Chapter 14, which covers exterior walls. Now, let me back up. Why do we care? Why do we care what the building code says or how it's structured? We care because it governs what we do as contractors and designers and installers every day. We have to comply with the building code. That is a baseline requirement. We have to do a bunch of other things, comply with the contract and the specs and everything else, but it all starts right here. So I think it's helpful for the audience to understand what the building code says, how it's structured. If you look at Chapter 14, exterior walls, there's a subsection, 1404, installation of wall coverings. Drilling down further, we have adhered masonry veneer, and then drilling down further yet, we have exterior adhered masonry veneer porcelain tile. So we know now that porcelain tile is a veneer. The code recognizes it as a veneer, and so everything the code has to say about adhered veneers applies to porcelain tile. And this is, I believe, the entire section of that adhered veneer, just so you can kind of see. And I know you can't read it, so I've blown it up for you here on this slide. What the code says, up until the 2018 edition of the code, because 2021 is when the code changed. So this is what it used to say. Adhered units shall not exceed 5/8 thick, 24 inches in one face dimension, and 3 square feet. In 2009, when this was put into the code, that was a pretty liberal, if you can think back to 2009, 3 square feet was a pretty big tile. And so that language stayed in for 2009, 2012, 2015, and 2018. So what we're going to talk about for the rest of the presentation is what happened between 2009 and 2018, and why are we so confident as an industry that we don't have to limit ourselves to 3 square feet and some of these other restrictions that sounded good back in 2009, but today we know that they're maybe a little overly restrictive. That 3 square feet looks like just graphically, it looks like a 16 by 16 or a 12 by 12 or even a 12 by 24. So just graphically, that's how that looks. So let's talk about, like I said, what's happening in the tile industry all these years, okay? These past 10 years up until 2021. Tiles were getting larger, tiles were getting thinner. So what that means is lighter. And just because the tiles are coming out monster size, they're very thin, so they're light. So they're relatively easier to adhere to a building in terms of weight and loads. We even have this new product category that I mentioned, gauge porcelain tile. So as this is all happening to the tiles, the mortar manufacturers like Mapei and Laticrete and Custom and Schluter and Ardex and all of them are working together to develop these super strong, super flexible adhesive mortars. And it's important for mortar to be not only strong in tension and strong in shear, but be flexible to move with the building substrates.
Scott, I think that was a point that was drilled home in the meeting on Monday.
Absolutely.
We talked about the flexible mortars. Mortar manufacturers are like, this is on us. Yeah. You guys need to tell us what we need to do.
Right, yeah, it's a good example of cooperation in the industry. Bigger tiles, lighter tiles, stronger mortars. This is key too, increased focus on labor. All right, we're not just letting anybody install our tile. The industry has banded together to create certifications, and the design professionals are paying attention to who's installing the tile. And hey, what credential does this contractor have? Is this a 5-star contractor? Is this a Trowel of Excellence contractor? Is the installer a ACT certified installer? So all these things are happening, and these are all good for everyone in this room, provided it's a good design and the design follows the guidelines. So we're gonna look at each one of these. Large format tile. I don't have to tell anybody here that tiles have gotten bigger, and which means more difficult and challenging to install, not only from a functional perspective, but from a aesthetic perspective. We have concerns like flatness and lippage and things like that. But the important thing for structure is to keep them, or for performance, is to keep them stuck. Right? We can't have tiles falling off buildings, and so large format tiles are. It becomes very important to pay super close attention to how the tiles stay stuck. So as tiles get bigger, warpage becomes more of an issue, lippage can become more of an issue, substrate flatness and tolerances become more critical. Bonding pattern can become more restrictive as tiles become larger, and the amount of contact between the thin set mortar and the tile also becomes important, because we have to have good coverage, especially on exteriors. Okay, so these are all things that are always important. The 5 items you see on the screen are always important, no matter if we're talking interior, exterior, walls, floors, doesn't matter. But when we're talking about exterior walls, these become, I would say, a safety issue, really. Yes. Yeah. All right. James, is warpage and wedging. You come in after this, right? And when we get to bond failure. All right. So just to illustrate, how big tiles create, we have these challenges. Is the caliber range, in other words, how big or small is that tile allowed to vary from the size that we think it's going to be, gets bigger, and as a consequence, grout joints become allowably wider because to make up for the dimensional variation. The thickness can be a variable. The tiles are not going to be flat, and the tiles may not be square. And if you're dealing with a 6-inch by 6-inch or an 8x8 or 12 by 12, it doesn't matter that much, but when you have 4-foot by 6-foot tiles or these gauge porcelain panels, this becomes really an issue. So to drive it home, this is a picture of a phone of a tile setter. He has a tile laid upside down across the bucket, and his level to show me, and he showed me this on his phone. He said, "Look, Scott, the tiles are not flat. These are badly bowed." And same tile setter showed me on his phone. He's in the same tile and same job. The tiles are not square. He put his square, and he said, "Look at how out of square these are." And so I'm very sympathetic to the installers and folks like James who deal with these struggles in the job site every day. And I will tell you that these tiles are 12 by 24, but they were imported from another country who is putting out material that does not meet ANSI A137.1 standards with respect to caliber range, warpage, wedging.
And one of the things, I could go down a whole 2-hour seminar on tile sizing and out of square wedging and everything else. Understand that their tolerances are allowed up to, some of these tiles are allowed up to 1/16 of an inch, closer to 5/64 in sizing, wedging, and sizing, calibration, wedging, and warpage as well, some of them. And so that's what we have to deal with in the field. And that's why talking about substrates first is so important.
Right. So bigger tiles, lippage. I think we all understand that lippage is an issue, but we have these lippage control systems that help us with lippage. This is a great just example of an exterior veneer job in Chicago, panel job. And if you don't know, the ANSI standards, so now we're talking about how tile has evolved in the last 10 years, right? So we have ANSI standards for installation of gauge porcelain. What you might not know is the ANSI standards require any panel job that's truly a panel, so in other words 1 square meter or larger in size, to be installed with lippage control, with a lippage control system. Don't even attempt to put this stuff in without lippage control. You have to. The standard says you have to. Yeah.
So Scott and I were talking when we were reviewing this PowerPoint about substrates, and I said, before we even get to the substrate, we've got to get to see what's on top of the substrate. So I was looking at a project as a consultant, and they were taking the tile off the wall, and you can see the middle picture right there. I threw water up on the wall because as this was coming down, that water never even went into the wall. It just came straight down. So obviously they had a bond breaker on it. Since this is tilt-up, what they did is they have form release on these tilt-ups to get them out of the forms, and when they put them up, nobody bothers to check to see if they have a bond breaker on them or not. And so what happens is the contractor on this one told me he power washed it, and I said power washing is not going to do anything because it's a solvent-based bond breaker. So before you even start checking the flatness of your substrate, you need to check to see if you could even stick to the substrate. The large format tile substrate tolerances are 1/8 and 10. Anything over 15 inches, you're 1/8 and 10. Variance, you can be no more than 1/8 and 10 out, 1/8 of an inch and 10 feet, both vertical and horizontal. Okay, so you need to think about that when you're running walls. You're running walls, exterior or interior. You need to make sure that your backer board's installed properly. It's got to be staggered. One of the things that we see a lot when it fails is we see the backer board staggering is not there. It's a straight line. And so you start seeing straight line cracking. And so you see this, the gauge that you need, the gauge tolerance right there, 20 gauge steel studs minimum on a 16 on center. And that's for the reasons for that board's not doing this when you're putting the tile in. You can see the staggering on this. It's done very well. This is one of the pictures you took off of one of your jobs.
But what's the problem here? Does anybody see what the... Look at the fasteners. I don't know if they're nails or screws, but look how far apart they are.
Yep.
Yeah. They're not 16.
And that shows it as well as about what's going on with the fastening and everything else. You got to have your fasteners where the cement backer board recommends, where the manufacturer recommends where these fasteners go. So one of the things that Scott has been really, really beneficial on the committees is we talk about flatness. And everybody looks at flatness as a floor. Well, lo and behold, we put tile on the walls too. And so your flatness tolerances have to be the same on the walls. It helps with minimal lippage. The large gauge porcelain panels, the GPTPs, don't have a lot of warpage in them. It's your 12 by 24s, your 24 by 48s. That's when you have a lot of warpage and a lot of coverage problems because of the bow in the tile, the allowable warpage in the middle of the tile. And that's why substrate flatness is so important. Proper coverage. Again, knowing, being trained and doing panels, you can get the coverage that is needed. And to me, it's a little bit easier. Yeah, it's harder to get it out and do all the mechanics of putting it up on the wall. To me, it's a lot harder putting a 12 by 24 or 24 by 48 up on the wall, because you're going to have some lippage issues no matter how flat that wall is because of the actual warpage of the tile. That's why proper coverage is important, because a lot of people don't get it underneath the middle of that tile. And of course, proper coverage leads to better bond. 95% minimum exterior, 80% interior, 95% dry, wet areas. There's a standard that's what designates a large format from a regular tile, anything over 15 inches. Why did we choose 15 inches? Because back when we wrote this into the ANSI standard, 16 by 16s came about. 16 by 16s were newish, and 15 3/4 are still within the calibration variance. And knowing how some people like to use lawyers, we had to encompass 15 inches. That's why that strange number's in there. Everybody asked me, why 15 by 15? 1/4 and 10 for regular tiles, smaller tiles, 1/8 and 10 for larger tiles, anything over 15 inches. And here it is vertically. This is, Scott, you took these from horizontal and just put them on end, didn't you? Mm-hmm. You can see how much of a variance that you can have and how much of a variance you should not have. The other kicker to this is, as well, is it's no more than a 1/16 of an inch in 2 feet. And that really comes into play when you're using, for me, my personal experience is on masonry. Okay, because there's tolerances for masonry as well for how they can be out of plane. But the 16 and 2, to me, really hits for me when I'm going over masonry. I don't know if anybody else has that experience. Here's a job that we're doing right now. Actually, we're doing in downtown Phoenix. You can see the 10-foot straight edge we used on it. That wall looked like a roller coaster. And the plaster said it's good to go, and I'm like, it's good to go for what? You know, they had to come back in and do 2 days of grinding on their mud to get it back within an 1/8 and 10. I said, I'll settle for 1/4 of an 10 because of what we're setting and how we're setting it, but it can't be this. This leads to spot bonding, because usually what I see as a consultant on the consultant side is when they're getting out of plane, they're using thin set to make up for being out of plane. And guys get tired and they get frustrated and they've had a bad day, so they start dot mounting the back of it. Well, that leads to coverage issues, especially in a freeze thaw area where the water will freeze behind the tile and blow the tile off, or shrinkage issues where the tiles start to pull down and then you start seeing lippage. This is an exterior one for, you can see what Scott took a picture of this to show the flattening material that they're using on the walls. There is flattening product made for vertical installations. The manufacturers, all manufacturers have a flatness material to make the substrate more flat, and you can see what they've done on the right-hand side there. Right there. The way it's supposed to be done. 10-foot straight edge. Every tile contractor that considers himself a professional has to have a 10-foot straight edge. You know, I've seen plenty of jobs where these guys are taking out 4-foot straight edges and checking the substrate. That does no good. It's got to be 10 foot. And it's also got to be, you've also have to have the ability to explain to your superintendent or to the owner why it's not flat. You can't just say because, all right? We have standards that we have to abide to. Manufacturer's recommendations, ANSI standards tells you this is how the substrate's supposed to be. It's supposed to be an 1/8 and 10 anytime we're over 15 inches on one side. This is mud work. This is the way it always should be done, but we can never get that. But you can see them screeding off on the wall. They did a really good presentation yesterday at the stage where they were showing how to mud walls with float strips and everything else. Absolutely the best way to put tile in if it's in the budget. this is a very key statement that we put in the handbook, I believe, a couple of years ago, isn't it, Scott? Industry standards for tile finish flatness and lippage do not apply if the substrate does not meet required flatness tolerances for the tile, unless the tile contractor is authorized to correct substrate flatness issues. Basically, what we're saying is, we've got a problem with the wall. It needs to be fixed, okay? We don't have the money for it. Okay, then my tile's not gonna meet the standard. If you don't wanna pay me to fix it, you're basically telling me that, I'm basically telling you that I can't make it work the way you want it to work. So all bets are off at that point in time. It's incumbent upon the architect and the specifier to make sure that that wall is where it needs to be. The general contractor follows up with that as well and be able to explain it in an intelligent manner. Yeah. Document it. The general contractor will not remember anything you tell him unless it's to his benefit. And then he'll remember that you spilled mustard on your shirt that Wednesday at 3 o'clock in the afternoon. If you don't have it in writing, it does not exist in the general contractor's eyes. Bonding patterns, our favorite. So there's multiple bonding patterns. As everybody knows, there's no 50% offset except when a mandatory mock-up is involved. And that's in ANSI language as well. You can do 50% offset, but the owner, architect, what is it? I'm sorry, the design professional. The design professional, the owner, has to sign off on that mock-up if you're doing a 50% offset. There are tiles that you can do 50% offsets on. Just cover your bases. Don't go, most of the manufacturers, in fact, yeah, 90% of the manufacturers don't go any further than 33% offset. Like, again, I explained to you the 50% offset. It can be done, but it has to be done with a mock-up. I've been on jobs as a consultant where first thing I've asked the tile contractor is, did you do a 50% mock-up? No. Okay, you just bought that then at that point in time. 50 versus 33. You can see the wall wash lighting. Ask for a diffuser. Do a mock-up. One of the things, again, I'm a big proponent of mock-ups. It costs a couple $100, I get that. But if you have that light over the wall where you're doing it, make the electrician put the lights in. You know, we're supposed to be setting tile in the conditions in which the tile is going to be seen at the end of the job. Do not be afraid to go to the general contractor and say, the electrician needs to put his lights up. But you have to have a reason for it. Again, explain it to him intelligently. And here's a 33. You can see that the lippage is not nearly as excessive as it looks because of the conditions.
Yeah, the 33 is a little better, but I would not say the 33 looks good.
No, it doesn't.
But the tile setters did the best they could with it.
Exactly.
Under the conditions. The material was terrible.
Yeah, I just looked at one of these Thursday before I left last week. Same thing. I went in there and measured the lippage, and it looked like it did on the right there. And the owner, it's a Goodyear, Arizona. The owners were going nuts. I'm like, guys, this is within tolerance. You know, it's one of my competitors that I'm consulting for. And I actually said, this is within tolerance. And they were beside themselves. Now you can see all the patterns they have in here, the 50%. You can see the ones with the warning signs on them right there. Those basically get you into that 50% offset. On the ones that have the yellow warnings, that's when you have a 50% offset situation, because of the way the ends of the tile are hitting the middle of the tile in these patterns. Scott, this is great. So even on their boxes, they did a great job. Scott said this perfectly the other day. They did a fantastic job on telling us how we can set it, except for herringbones. Herringbones put the end of your tile to the middle of the other tile that's adjoining it, so you can see the lowest point of your warpage is hitting the highest point of the warpage in the tile by it. I'd stay away from herringbones. Right there.
All right, I think this is old news by now. We have a product standard, we have an interior installation standard, but what is relatively new is now we have an exterior installation standard. So we're here today to talk about exterior adhered porcelain tile. 108.20 is the standard that governs that installation. If you're not aware, gauge porcelain tile, the whole reason we have it has its own standard versus the A137.1 conventional porcelain tile is because gauge porcelain is so different. It goes in differently. It goes in with different tools. You have to move it around the job site differently. It is different in every way. It's a different set of skills, all right? And we want you, if you haven't worked with gauge porcelain tile, we want you to. We want everyone to learn how to work with it. Don't try to teach yourself. Go to one of the classes, one of the orientations. Talk to the IMI or one of the organizations out there who can help you get up to speed and get your installers up to speed. But I don't want to go too deeply into the differences. I just want you to understand that gauge porcelain tile installation requires an entirely separate set of skills, everything from spreading the mortar to embedding the unit to the type of mortar you use, the type of tools you use.
One of the things too is, Scott, you're talking about the panels. Mm-hmm. As we see more and more prevalently now, a lot of these panels are being cut down into smaller sizes. And like I said before, you're going to get better coverage on these flatter panels, even when they're smaller, because they don't have the warpage that the regularly made large modules have. They don't have that same warpage in the middle of the tile. So adherent mortar coverage is imperative, and substrate flatness is imperative in this. They're actually better for coverage done correctly than a regularly made tile.
And as James mentioned, on exteriors, the code requires, ANSI requires 95% coverage, and that means embedment. Coverage by its, I don't want to say the word definition, but we understand as an industry that it's not enough to just spread mortar over 95% of the substrate and 95%, we hope 100% of the tile, but you have to make sure that the tile is embedded to that percentage. So the picture on the left, there's plenty of mortar. It just hasn't been installed the right way. It hasn't been troweled consistently. Whereas the picture on the right is what we hope to happen when the tile is embedded.
And for everybody out there who's an architect, designer, who doesn't go to the job site that much, you can tell the person who's installing the tile and knows what they're doing. On a rectangular tile, those trowel marks need to be perpendicular to the long side, okay? That way you can collapse the trowel marks when you're putting it in. It's simple geometry. I was on a job the other day. The installers were using a 1/2 inch by 1/2 inch trowel, 45 degrees, so they have a 1/4 inch notch on the wall. They're trying to put it in. They're moving it maybe a 1/16 of an inch. I'm like, guys, simple math. You got to move it a 1/4 inch each way to embed that to collapse the trowel marks. Okay, so that's another thing you need to look at for as an installer. If you're using whatever trowel size you're using to install it, they need to make sure they're collapsing the trowel marks. They can't move it a little bit. They've got to move it at least the width of those trowel marks to collapse the trowel marks and evacuate the air out of the mortar.
And in the case of gauge porcelain panels, you're not moving those panels once you set them. So we have other methods of embedding, of collapsing the trowel marks. So we know coverage is important. It's very important for exterior veneers because people are walking and we don't want tile falling off the wall. So the standards say if 95% coverage is specified, so in other words, if the tile's going on and outside of a building, back butter each tile with a bond coat. So back buttering for gauge porcelain tile is done a little bit differently. Did you have a question, Craig? I did. Yeah.
So it actually, in the 1920, it says 80% coverage for exterior.
For gauge porcelain? Okay, yeah. For some reason, gauge porcelain requirements for exterior are different than the exterior requirements for conventional. For conventional, it's 95%. I cannot tell you why, and I don't even want to have that conversation right now. It's 80 for, but I think we all want to have 100% coverage all the time, no matter what type of tile, no matter where it goes. So for the sake of argument, let's work toward 95% coverage for exterior.
Right.
Okay.
Let's and we got rid of the word back butter in the new ANSI 1085. We call it flat back troweling because some people consider back buttering back troweling the tile. We don't want to see that.
Yeah.
You don't want to be back troweling. Yeah, that's correct, and that may be right. They did it in 119 or in 19 and 20. We'll have to go back and look at that because it's relatively new. I wasn't part of those discussions. I mean, we were part of the discussions. I don't know exactly what happened there.
Yeah.
We'll talk. We'll resolve that question.
So think about if your installers are putting these panels on an exterior wall, it's taken a long time, and these large panels it's a two-person job. I'm standing over on one side, and my partner's standing over on the other because my arms and her arms aren't long enough to reach. So it's a very, very time-consuming job to back trowel mortar on the back of the tile, and then we've got two other installers at least spreading mortar on the substrate. We want this mortar to not start to skin over by the time we put the tile up, and we're putting it up 20 feet in the air, all right, with a lift. So if you don't have a lift, you may be buying a lift if you want to start bidding exterior veneer tile work. So this back buttering, which is on the picture on the slide here, it's done on the ground, and there's all kinds of walking around room. I do know of jobs that were done. The back buttering was done from the lift in a very confined area. So a lot of planning has to be done on the part of the contractor to make sure that the mortar is applied at the right time and quick enough. And the right mortar. It's probably going to be a longer open time mortar, and we hope it's an ANSI A115 mortar. We're getting to the flexibility part in a minute, but so many considerations go into installing tile on an outside of the building. No spot bonding, hopefully not only because you can see the spots in the case of this light colored stone, but it's just not a good way to bond. Functionally, it's not a good way to bond tile to a wall. So we have a soffit. It's another project on the right. And when I flip the slide to the next slide, I'll show you how the owner solved this problem. Right? They didn't go back and replace those tiles. They put a sign. And Gavin, by the way, I drove by this project 2 weeks ago. The sign is still there. Yeah, they still haven't done it, and that was at least a year ago. All right, let's talk about bond strength. When we look at bond strength for adhesive mortars, we look at a mortar's shear bond strength and its tensile bond strength. Its shear bond strength is easier to if a tile is a more accurate measurement of if the tile were to fail or if the mortar were to fail, it would probably fail in shear and not tension, unless we go back to the picture of the soffit. Here we have this mortar failing in tension because the tile wants to just, via gravity, just fall off. But more often than not, we have tiles failing in shear. The example on the right, the thin set needs to hold the tile in place while the gravity of the tile wants to make it fall down. So there's shear bond and there's tensile bond. You can read the definitions on your own. It's easier, as an industry, it's easier for us to check for tensile bond strength, and that's an indicator of the shear strength. Without going into too much detail, it's just a less destructive of a test when we test for tensile bond than it is for shear bond. But let's take a minute to look at forces and what kind of forces an exterior of a building would undergo to cause these shear forces in the building. So for lateral loads, a building is going to deflect, hopefully not as much as you see in the picture, but the building frame will change size. We'll literally, let me just skip to the next one. Oh, I thought I had, okay. The building frame will literally change size, okay? So it elongates on the windward side, and on the leeward side, it shortens. The tile wants to stay the same size. The tile is not going to get bigger and smaller like the concrete frame or the steel frame and whatever backing material is spanning between the floors. So the mortar, the thin set mortar, is what takes up that movement, and it should be flexible enough to accommodate movement of the structural frame while keeping the tile stuck. So that's... Yeah.
And a lot of this needs to be done on the engineering side, because remember, you do have wind loads. You know, and Vegas and Phoenix have similar climates, so we do get 60-mile-an-hour winds all of a sudden. And also, that building will move. That building will torque as well. It'll be twisting. The higher it goes, the more it's going to twist. And so that all has to be engineered, so it's very important that you're choosing the right mortar.
So if you look at the tables 6 through 10 for mosaic tile, quarry tile, pressed floor tile, glazed wall tile, and porcelain tile, that's all the tiles covered in A137.1. Every single one of those tables is going to tell you minimum shear strength 50 psi. In reality, the shear strength of that mortar is going to have, the shear strength of the tile, I should say, is going to be a lot more than that, but 50 psi is the benchmark number that is referenced in the A137.1, and it's also incidentally referenced in the International Building Code for Veneers and the TMS 402 code, which is the building code requirements for masonry structures. So that 50 psi is commonly recognized across many exterior wall industries as a benchmark for shear strength. There is a test that in the ANSI standards, it's a laboratory test, taking two 1-inch pieces of tile, 1 inch by 1 inch, putting it in a jig with a 1/8 of an inch thick mortar joint and applying a load to the point of failure. And when that mortar failed, so you see the sample there before the failure, and then that press comes down, and we can measure how much force is being applied. And when that mortar shears off, that is the failure point of the mortar, of the assembly, really, because the mortar has to be cohesive enough to hold its own strength, and it also has to stick to the tile, and it also has to stick to the substrate. In this case, the substrate is the tile for that test. But on a job site, you can really have about 5 modes of failure. Some are more common than others. So we can have a failure of the tile itself, a cohesive failure of the tile itself. That's probably not going to happen unless it's a very brittle, it's like a slate tile or something, and there's some very unusual forces. More often than not, it's going to be one of these next 3. It's going to be adhesive failure between the tile and the bonding mortar, or the bonding mortar itself will fail in cohesion, or adhesive between, and like you talked about bond breaks. We have to have a good bond between the substrate and the adhesive mortar. So that would be an adhesive failure between the adhesive.
Things I see on adhesive failure too is, especially in this area, and I can only speak to our area, Las Vegas and Phoenix, is I see a lot of tile contractors, one of 2 things happens on adhesive failure. Either they let the thin set skin over, they got too far out in front when they were spreading it, or secondly, they're actually storing the tile in the sun. So when they stick the tile in the sun, it's 110 degrees out there. That tile becomes 150 degrees. It just burns the surface of the thin set, basically skinning it over at that point in time.
Mm-hmm. Mm-hmm. And somebody asked a question in the ANSI meeting, what about paper-based products like exterior gypsum material? And that would maybe a candidate for this final method, cohesive failure within the substrate. If you're trying to stick your tile onto a substrate that's just not stable, that substrate could fall apart in theory. So we're not trying to scare anybody here, but we're just trying to acknowledge that if you're going to put large tiles on exteriors, be careful, know what you're getting into.
Yeah, because if done right, it's going to stay there forever, theoretically. Mm-hmm. And so what we're saying is we're saying here's what you need to look out for on both sides.
Yeah.
Designing and installation.
So ASTM-C 1823 is a test developed by the Dimension Stone people. It's a tensile test. So this measures the tensile strength, which, as I explained a minute ago, is different than the shear strength. But we can apply what we learn from a tensile test to the shear strength of the mortar. There's not a direct correlation, but if the mortar fails in tension, it's probably going to fail in shear, and vice versa. It's just a good indicator, and it's less destructive because you're pulling out, well, it does say shear bond strength. Oh, this is I beg your pardon. This is the destructive of the 2. This is the more destructive, because we've got to take out several tiles to see if the mortar is going to keep its shear strength. The tensile one's where we just try to pull one off, and that's more commonly done because it's a cheaper test and it's less destructive. So to recap, shear, avoiding failures in shear bond. Let's make sure the substrate is good. Let's make sure the tiles are good. Let's make sure the mortar is good. And when I say good, I mean appropriate for the application which it's being specified. Coverage, and what I don't have on the slide and I need to add is, you see those 2 men, make sure those installers have the credentials and know what they're doing. You can't take someone off the street and call them a tile setter. They have to have the training, and that's key. Let's talk a little bit about mortars. So we know tiles are getting bigger. We know mortars are getting stronger and more flexible. And in fact, we've had A118.1, which is a non-modified mortar, sometimes called dry set mortar. No latex, no polymer additives. This is the old school way of adhering tile. All right. A118.4 came along. Don't ask me what year, but these chemical companies who make thin sets started adding chemicals like latexes and polymers to enhance the stickiness of the mortar, because for things like porcelain tile and glass tile, which are impervious materials and don't have pores for the cement to travel into to form a mechanical bond. So when a mechanical bond cannot be achieved, a chemical bond needs to be achieved, and that's why we have polymers. So we have modified. That word modified refers to the modifiers in the mortar, the polymers. In 2013, so we're on these intervening years leading up to the new building code. In 2013, the setting material manufacturers said, we need to make a premium mortar that has better shear strength and better adhesive strength than this 118.4 mortar that is just all over. You know, you could get really, really good 118.4 mortars or really bad 118.4 mortars. A contractor like James, who always wants to do the right thing, would pay the extra whatever it costs for the premium A118.4 mortar, but maybe one of James' competitors would try to buy a cheapo type of 118.4 mortar, and it got to be a problem. All right, so as an industry, we created a new category of 118.15, which is stronger in shear, stronger in tension, and more flexible. So we have expansion coefficient. The expansion coefficient for tile in freeze-thaw climates is approximately 0.2 of a millimeter to 0.4 of a millimeter for tile movement. So the mortar whatever the tile is going to move, the mortar should be able to move equally. And if it doesn't, you'll have delamination. I'm not going to read you this slide, but I do want to let everybody know at a very high level that whether you're speccing a 118.4 or a 118.15 mortar, there are mortar designations. And your mortar can have more than one designation. An H designation would be a mortar for large and heavy tile. The ANSI standard has given that H. When you see H, it's mortar for large and heavy tile. It's just specifically formulated for that type of application. F is mortar for, if that is fast setting. On the other end of the spectrum, E is extended open time. So we've got fast setting and we've got extended open time that work. You can never have an F and an E. It's going to be one or another. But you can have an H and an F, and you can have an H and an E. You can have one mortar that meets more than one, as long as the F and E are not two. And then T is non-sag. T stands for thixotropic, but it's the non-sag properties, good for keeping the wall mortar stuck. So in that right-hand column, A118.15, these are the properties of this special, improved, enhanced, whatever you want to call it, performing latex modified thin set mortar, which I think you should be using. If you're putting tile on an exterior, you should be using the best mortar you can get. Yeah.
Absolutely. You don't save 10 cents a square foot to go on the outside of a building. It's just cheap insurance. That's basically what it is. So I'll talk about what seems to be, in my perspective, and I'm not going to throw everybody in this room under the bus, the bane of some of the designers about movement joints. Movement joints are absolutely necessary on the exterior, especially in my area. We have surface temperatures of 118 to 120 degrees. Just the air temperature, surface temperature will get to 200 degrees without a problem. Every 8 to 12 feet, for my area, I would recommend no more than 8 feet. In the Vegas and Phoenix area, I wouldn't go more than 8 feet. 8 to 12 feet on center, temperature change up to 100 degrees. The width of your expansion joint is important also. What's great about the TCNA handbook under EJ 171, it gives you the calculations on which the width of your movement joints need to be. You know, just because you're using an 1/8 inch joint doesn't mean that movement joint's an 1/8 inch. That movement joint can be as much as a 1/2 inch or 3/4 of an inch, depending on air temperature and the span of that installation. Interior, it's 20 to 25 feet. Also at the perimeter. One of the things that everybody forgets on the interior is that you need a movement joint at the perimeter, at abutting walls, dissimilar surfaces. That's where you're going to see your grout crack if you don't caulk it. And then interior exposed is 8 to 12 feet. Think of a big giant lobby with big windows and glass doors. It's going to be treated just like the exterior with the heat. This is because the installer decided that he did not want to put movement joints in. This is 40 feet in the air. These pieces are 18 by 36 by about 3/4 of an inch thick. One of them fell and almost hit a landscaper. They ended up having to build a tunnel in and out of the building. No movement joints in Phoenix on the south side of a building. That's what happens. This is, Scott, I think this is yours.
No, it's still yours.
Still, I mean, this is the slide you showed me.
Oh.
This is your slide where they,
Oh, it is.
yeah, where they spot bonded it, had no movement joints. That's an excellent recipe for failure. The biggest issue I have as a tile contractor is the failure to communicate with an architect or a general contractor. This is a job we're doing, 6,000 feet in downtown Phoenix, exterior 6x36 wood planking tile. I need to know where my movement joints go. Didn't hear anything, so I sent an email. Please give me the movement joints. Architect, expansion joints aren't needed for the project. Our plans show that there's expansion joints in the stucco substrate. It doesn't work. Again, please provide my movement joints for me. I am not an engineer. I'm not a design professional. I just stick things to other things. That's what I do. Not sure we need an expansion joint for wall tile. The surface areas are small where we show the wall tile. Some of these are 20-foot by 8-foot runs. That's big enough for a movement joint. Exterior. Have me provide a suggestion. I can't do that. No tile contractor should ever do that. Once you design those movement joints in, it's your project now. You're not an architect, you're not an engineer. If you are an engineer, congratulations. And then I came back and I said, okay, the specifications tell me that I have to follow TCNA and ANSI. That's what the specs say. Write me a letter to say that I can go around it, or reissue me new specifications, because right now, if you make me do this, I'm in breach of contract. Never be afraid to do that, because it's your butt on the line if that tile starts to fail. Lack of movement joints. So on the left hand, I'm doing a quality control 25,000 square foot installation, 40 feet high. All these joints are to be sealed. They're all sealant joints. There's not one grout joint on here. All the joints on the stone tile will use a sealer. On the left, you can see that they've bridged the joint with thin set. That has to be cleaned out. Okay, else that's not a true movement joint, because the tiles are bridged together back there with the mortar. On the right, didn't have a flash, but that joint's clean. That's the way it's supposed to look. Expansion joints over reinforced mortar bed, they're in there. You can see it. They have them placed every about 8 feet on this. Do you have? Oh, sorry. I'm sorry.
Yeah, I'll go back too.
Yeah.
Yeah, so you can see the vertical. These are actually every 4 feet. Yeah.
4 feet. I'm sorry.
Because this is a 12 by 24. It's hard to understand the scale. It's just a one-story building. So why would we see them every 8 feet, or sorry, every 4 feet?
Because they're worried about movement.
Right.
Absolutely.
Right.
And one of the things I understand from the architects, we don't want to interrupt the pattern and everything else. Well, we approved movement joints a couple of years ago that they can be offset movement joints, where they can go through the tile offset. Okay. But I'm telling you right now, as an architect or an engineer or a designer in this room, movement joints are required, not only by standards, but every manufacturer who makes mortar or grout requires movement joints. It even has it on their bag, and in Spanish and English both. Okay? So when in doubt, read the bag.
And can I point out too that you'll notice in the TCNA detail that the expansion joint doesn't just go through the tile. It goes, the mortar bed, the reinforced unbonded mortar bed, has a gap in it. All right, so this is kind of a generic detail, but the takeaway is the movement joint should go through the whole entire assembly. And that's good. That's what's happening here. You can see the channels. I mean, I happen to know that these are vertical channels that have a gap between them. So we're taking, this is a good example. I should have put one of my smiley faces. This is a good example of the movement joint going all the way through the substrate, all the way out to the finished material.
Here's 2 movement joints for backer board. As you can see, one's at the framing, where they did it at the framing where you can go through the backer board. The other one just goes to the backer board. You know, you make a decision at that point in time. You try to tell the general contractor, I want movement joints at the framing, and try to space those to where it's compatible with EJ 171. Otherwise, you're taking it upon yourself if you don't do that, and you're just putting it to the surface.
But James, let me throw something at you. Which EJ 171? Gavin and I were at a job where the architect, and there was a failure, the architect had just said, follow EJ 171. Well, here we have on the screen, there's an EJ 171K and an EJ 171L, and they're showing 2 different things. One of them shows the movement joint all the way through the substrate. The other one shows it only through the tile. So in this particular project, the contractor only provided the movement joint through the tile, and we had buckling and cracking and things. And the architect said, well, you messed up, Mr. Contractor. You didn't go all the way through the substrate. And the contractor just said, well, you didn't tell me which EJ 171. So I think it's as specific as you can be. It's like you said a minute ago, communication is so important. And if you're getting a vague answer from the architect, press him. Press the architect for more specific direction.
And I'm not going to put it all on the architect either. As a professional tile contractor or installer, you're supposed to know this. I mean, it's flat out there. It's in there. It's been in. We've had standards for 60 years. The book, you can get the books online. If you're going to be a professional, especially if you're going to do exterior, interior, anything, movement joints are required, and you need to know which movement joints. It's okay to ask the questions. It's okay to be more knowledgeable about movement joints than the architect. They need to do their due diligence coming back at you, okay? These movement joints, as Scott and I said, they have movement joints, but they're spaced too far apart. Maximum spacing is 12. I think, what do we calculate here? 16 or something to that effect. They're missing one in the middle. There you go. So qualified labor, when Scott touched on this at the beginning. Scott has this, and Scott, due to Scott's hard work, got this put into master spec about qualified labor. NTCA's qualified laborers, we have 5-star contractors, which means a certain percentage of our people have to be CTF certified. I believe we're going beyond that, where one of our people or a percentage has to be ACT certified going forward. You have the ceramic talent CTEF with the U.S. Department of Labor. Union contractors, TCA, has the Trowel of Excellence. So those are the type of installers you need to be looking for to install these types of projects.
So I'll talk about ACT for a
Right,
minute.
yep.
ACT is at the pinnacle of installer qualifications, and ACT is a program that was collectively developed by the organizations you see at the bottom of the screen, and TCA, IMI, BAC, everybody there, TCAA. We have, and I'm not going to talk about all these, but I want you to be aware there are 7 distinct special certifications, special skill area certifications. Back in the early 2010s, the industry got together and we said, what do tile setters really, we know they need to be good at everything, but what do they really need to be good at? And as an industry, we identified these 7 things that they need to be good at, and we developed very, very detailed certifications for each one of them. Since the topic that James and I have been talking about for the last 55 minutes, so we better wrap this up, is exterior adhered veneers. That's large format, mud walls, and gauge porcelain tile. So there are certifications that address exterior adhered veneers. At a very basic level, it's a 3-step process to become certified. Step 1 is you have to have years of experience in the field. You can't be new to the industry. So once you demonstrate that you're an experienced tile setter, you schedule yourself to take a written test on the TCNA handbook and the ANSI standards specific to whatever you're testing for. So let's use large format tile as an example.
And I struggled with that test too.
Yeah, it's a hard test.
It's a hard test. The ANSI TCNA test is hard.
Yeah. It's an open book test, so you can have those reference materials out and you can look up the answers. We don't expect you to memorize the information, but we want the installers to know where to find the information. So if and only if the installer gets an 85% passing grade on that written test, they can schedule their final one, and that's the hands-on test, and it's the driver's test where an evaluator observes the installer building one of these mock-ups, and it's anywhere from 4 hours to 6 hours, and they're evaluated on a set of critical points. You know, for large format, since that's the example, they're evaluated on layout, they're evaluated on coverage, they're evaluated on lippage, on grout joint width and uniformity, on flatness of substrate.
And I'll give you a secret on the other one on the left for large module substrate prep. So I was co-chair with Brad Trostrud on this one, and we found out a couple of years ago, I don't know if it's still true, but that was the one that failed the most because they could not get the coverage underneath the middle of the tile. That's why I keep pounding on coverage, flat surfaces.
Yeah. All right, let's bring it home. So we spent a long time on number 3 because we wanted you guys to understand all the things that happened over the past, between the 2009 IBC and the 2018 IBC. So we're ready. We're ready as an industry. Here we are. The International Code Committee is considering what changes to make, if any, to the 2021 IBC. So what a group of us did, and it was led by the Tile Council of North America and the International Masonry Institute, our 2 organizations, with a lot of help from Crossville and MAPE and a lot of other people, NTCA. We proposed changes to the International Building Code, and this is what the proposal looked like. So we had 3 members of our industry fly out to, I think it was Dallas or San Antonio or something, and make a presentation to the International Code Committee. Everybody gets 2 minutes to give a compelling argument on why they should accept our proposal, and all those hands raised are the committee saying, yes, we agree, we vote in favor. It was a unanimous decision to accept our proposal. Now, what was our proposal? This is our proposal, and this is how it looks in the code. I don't want to read all that to you, so I'm going to put it into some bullet points. Remember how we used to have this from 2009 till 2018, 3 square feet, right, 24 by 12. What we proposed and what was accepted for the 2021, and if you go buy a code book today, the 2021, this is what you'll see. It says that if your tile is 1/4 of an inch or thicker, you can go as large as 9 square feet. So a 3 foot by 3 foot or a 2 foot by 4 foot. All right, for 1/4 of an inch or thicker. It's PSF, but I'm doing the conversion, the pounds per square foot conversion to 1/4 of an inch. And the code says if you're using one of those thin tiles, less than 1/4 of an inch, you can stick tiles to an exterior, porcelain tiles that are as large as 17.5 square feet. So that's a nominal 3 foot by 6 foot or a 4 foot by 4 foot. And this is huge. And I think that, and by the way, that came about by taking a 1800 millimeter by 3600 millimeter, which is I believe today, unless something has changed, is the largest panel that's being fabricated at the plants in Italy and Spain. Cutting that into quarters, and there you have your 3 feet by 6 feet, roughly. So, we've had projects that have used this, and if you look at the 2021 handbook, there's a great project. I just want to kind of wrap up, and I know there's a lot of contractors here, and there's a lot of installers here. This is a huge opportunity for you to make a shift in your business if you want to. You don't have to, but we're going to see an increasing demand for exterior tile. Now that the code lets you do it explicitly, you could do it before these changes, but you'd have to go through a little bit more hoops. But the code is very explicit now. It lets you put these large tiles on exteriors. And, which we think is a great opportunity to expand the market for our industry. You know, what used to be EIFS, what used to be metal panels, what used to be fiber cement can now be porcelain tile adhered.
And Mike, and I want more tile on the outside of buildings. I just want to make sure it's done correctly. Mm-hmm. I see a lot of failures. That's what I do. Some of the things I do, and it's basic things like I was showing you right there. Done right, tile will last forever. It will. Porcelain tile will last forever. It's just got to be the communication, the accreditation for your installers. Those are the key components in making a successful installation. Knowing what to do and knowing how to communicate back and forth with the architect or the end user. That's what you guys need to keep. Communication is key.
Questions? Martin. We would love to. The question was a qualified. You're not laughing. Sorry, I laughed. I'm not laughing. I'm not laughing at you, but yeah.
I'm involved in 3 cases right now of exterior facades that are failing in the Bay Area by reputable tile companies
Yeah.
who got forced into installing tile without grab joints. And I've sat in the room with the architect who did not understand that either the need for grab joints or he did not understand continuous movement accommodation joints.
Yeah, no, it's a great question, and for the benefit of the camera, the question was, how about a qualified architect? You can have the best contractor in the world, but if you have an architect who doesn't know what they're doing, it's got failure written all over it. And
He's limited to his liability through professional services.
Sure.
Where the contractor gets the full, he takes the full rap for that.
Yeah.
For something that he has in writing
Yeah, so a couple of responses are, as an industry, we have made great strides, just like you saw the strides we made with the materials over the past 10 years. I think we've made strides on the education. There's a lot, we're not there yet, but I think as an industry, we have organized ourselves to preach the gospel of good tile design and code-compliant tile design and conservative tile design to the architects and designers who are out there designing tile projects. We're never going to speak to every architect in the world. I wish we could, but we have webinars, we have things like the IMI, Tile Contractors Association of America joint seminar series where we go from city to city to city, putting on half-day or full-day programs for architects and spec writers. We get the information out there. The Tile Council Handbook is often purchased in bulk by suppliers and then given away free to design professionals, and that's a great program. We want to get the Tile Council Handbook and the ANSI standards into the hands of all the architects. So I definitely sympathize with you, Martin.
Not picking on you because you're an architect.
Yeah.
Just like we're playing our part on the installation side, it would be nice to see it be on the other side too, from the architects who can also
And you and I, Martin, you and I have had this conversation ad nauseum. One of the things like I keep preaching is communication. As a tile contractor professional, I have to have the ability to communicate in the architect in such a way they understand. Again, I can't just sit there and say that because that's the way it's done. Well, but well, and then that's what I'm saying, and that's why you have to have pushback. That's why I said, you know, if you're not going to do this the way it's supposed to be done, and you guys have to understand this as tile contractors. Your butt's on the line on that job if it fails. And it's okay to push back and say, hey, I've already got the contract. Nobody's going to cancel your contract. You've got one. All right? But if the architect or the design professional or the general contractor wants to go outside your contract, they're basically putting you in breach of contract at that point in time. And it's okay to say that. You know, I wouldn't lose that fight over a shower wall, but if I'm putting 15,000 feet, 50 feet in the air, 15,000 feet of tile, I sure as hell am going to have that battle, and that's the battle you need to have.
And this might come as a surprise, but some architects don't trust contractors. And so I will make an open invitation. If you would like some help reaching an architect, call me. I've got business cards up here. This is what the IMI does. We talk to architects. My team and myself do essentially nothing but give presentations like this, lunch and learns, we call them, continuing eds, you know, whatever. And so if you don't feel like you're being listened to as a contractor because you have some kind of agenda and you want to put more money in your pocket or whatever, and some of these are very unfounded. I understand that. You reach out to the IMI or somebody like us, and we can deliver that message from a neutral third party, and we can say, well, Martin's right. He understands the standards. Let us help interpret the standards for you.
And what helps you on that conversation is continuing education from installers. Yes. Have that CTI behind you. Have that Trial of Excellence. Have that 5-star. Have the ACT certification. We're no different than attorneys. We're no different than teachers or doctors. We have to continually educate ourselves. Hold yourself as a professional. That's what you're doing. You're not a hobby. This is not a hobby. This is a profession. If you don't treat this as a profession, then you should probably find a different profession.
I think the problem is we need to get that message out sooner rather than later so there aren't more failures, so that it does continue to grow. Because if we keep seeing the failures that we see today, that market's going to go away.
Oh, absolutely. So Scott on his end needs to attack the architects on their end. On our end, we need to keep pushing certification, 5-star Trial of Excellence. You know, remember, this is not a union, non-union thing right here. The union, non-union contractors got together 10 years ago to make this work for the betterment of the industry. And that's what everybody in the industry needs to know, from architects, designers, owners. Yeah. We got together, put our differences aside and said, hey, if we continue going down this road, LVT is going on the side of buildings, okay? We don't want to see that. So we need to do our part as installers. Martin has a very valid point. I'm on a job right now where I'm fighting with an architect over it. But I'm standing my ground because I know it's best.
In 2018, when GPT was brand new and the standards were just published, Noah Chitty, who was the chairman, who's with Crossville, the chairman of the committee who was in charge of the installation standard, Noah and I went to the CSI National Conference, which is a group of architects, CSI's Construction Specifications Institute, in Long Beach, California. That was where their annual conference was. And he and I did a 2-hour session on GPT, and it was very detailed. So and that's just one example of thousands that we do. And the suppliers, I don't want to discount them. Every tile supplier and thin-set supplier probably has a CEU program that they go out and deliver and have staff, their ARC reps deliver on a daily basis. And I'm going to go out on a limb and say they're all good and they're all right. I hope. You know, there's some varying qualities out there, but.
Everybody who's an installer and part of the NTCA or part of TCAA would love to see. We'd love to see more architect participation at TSP.
Yes.
You get the Total Solutions Plus. You get them in front of a bunch of qualified installers,
Yeah.
and then all of a sudden maybe they start to trust the installers that have the ACT certification, 5-star Trial of Excellence behind their name. But that's one of the things I'd love to push for is to get architects to TSP, so they can meet us one-on-one and say, hey, they are not part of the unwashed masses. They're actually professionals.
Right. Well, we're 10 minutes past. James and I can stick around as long as you want. I know some of you have to get moving, but thank you very much for your attention.